Think about how many hours you've literally lost just trying to get a project to run on a new laptop. It's exhausting, right? Well, welcome to this explainer. If you're a focused learner looking to truly understand the core mechanics of modern software, you are absolutely in the right place. Today, we're focusing on Docker basics. We're going to unpack the fundamental tool that completely shifted how modern applications are developed, packaged, and deployed across the globe. Grab your mental notepad, because we are getting right into it. Okay, let's quickly map out our journey. We'll kick things off with the ultimate developer headache, say hello to Docker containers, and then explore images, Dockerfiles, and Docker Hub. After that, we'll dive into compose, volumes, and networks, and finally wrap up with Docker versus Kubernetes. We're going from a universal frustration all the way to massive enterprise-level orchestration.
Section 1. The ultimate developer headache. But it works on my machine. Seriously, if you've ever worked in tech, or even just tried sharing a complex file with a coworker, you've probably heard, or maybe aggressively shouted, this exact phrase. It's basically the battle cry of messy deployments. You write this brilliant code, it runs beautifully on your laptop, but the second you hand it over to QA or a production server, boom, complete disaster. Missing libraries, different operating systems, conflicting dependencies. It is just an absolute nightmare of wasted time.
Well, enter our hero, Docker. Docker literally ensures that code runs identically across all environments. It completely cures this headache. By packaging your application up with absolutely everything it needs to run, Docker guarantees that if it works on your machine, it's going to work everywhere, the exact same way, every single time. No excuses.
Section 2. Welcome to Docker containers.
So what's really interesting here is the careful balance of isolation combined with sharing. A container is basically a super lightweight piece of software that holds your code, your libraries, and your dependencies. But here's the secret sauce, right? It actually shares the host operating system's kernel, all while keeping the application completely isolated from everything else running on that machine. You get all the separation you need to keep things safe and consistent, but without the heavy baggage of running a full-blown secondary operating system.
And because of that clever design, you literally get your time and your server costs back. Containers are dramatically faster to start up. We're talking milliseconds here, not minutes. They're also way less resource hungry because they aren't dragging around this heavy OS payload. And, for sure, they're completely portable across environments. So whether you're running it on a local server, up in the cloud, or just on your personal laptop, the container operates exactly the same way.
Section 3. Images, Dockerfiles, and Hub.
Let's move along and see how this actually builds in real time. Think of it kind of like a factory assembly line. It all starts with step 1, a Docker file. This is just a simple text blueprint of instructions. It tells Docker exactly what software to install and how the app should run. Then, in step 2, those instructions are packaged up into a Docker image, which basically locks all your code and dependencies into this immutable snapshot. Finally, step 3. When you run that image, it becomes a living, breathing container. So, you write the blueprint, you print the package, and you run the app. Simple as that.
But you don't always have to build things from scratch. That is exactly where Docker Hub comes in. Docker Hub is Docker's official cloud-based registry. Just think of it as this massive central library. Developers all over the world use it to store, share, and, most importantly for us, download pre-built Docker images. Why reinvent the wheel when someone else has already perfectly optimized it, right?
Say you need a database for your project. You don't need to spend hours configuring it. You can instantly pull a pristine pre-built image of MySQL or MongoDB directly from Docker Hub. Or maybe you want to set up a coding environment. Just pull down Python or Node.js. Literally in mere seconds, you have a fully configured, isolated environment ready to go. It is an absolute game changer for productivity.
Section 4. Compose, volumes, and networks.
So the crucial point we need to hit on is this. Starting containers manually, one by one, is exhausting and highly prone to error. Because honestly, rarely do you deploy just a single container. Enter Docker Compose. This tool lets you define and manage multiple containers together as a single application. You just write all your configurations into one docker-compose YAML file, run a single command, and boom, your entire multi-container application spins up in perfect harmony.
But there is a catch with containers. By default, anything you create inside a container is temporary. If the container stops or is deleted, that data is gone forever, which is obviously terrifying if you're running a database. Well, the solution is the Docker volume. A volume is storage kept securely outside the container's temporary file system. It ensures that crucial files, databases, and logs are kept safe and completely reusable, totally independent of the container's lifecycle.
And of course, these separate containers actually need a way to talk to each other. Docker Engine handles this right under the hood through Docker networking. Using mechanisms like the default bridge, this basically creates a secure internal internet just for your containers. It lets them collaborate seamlessly without exposing any vulnerabilities to the outside world.
Section 5. Docker versus Kubernetes.
Now, before we bring in Kubernetes, it's really important to acknowledge Docker's own built-in solution for scaling. Docker Swarm is Docker's native tool for clustering and orchestrating. It lets you group several different servers into a single cluster and run your containers across them as if they were just one giant system. It's fantastic. But if we look at the broader DevOps landscape, there's another heavyweight champion we absolutely have to discuss.
And this brilliantly illustrates the crucial distinction between the two most talked about tools in modern software. Docker is your platform to build, package, and run containers. It's best suited for single-node creations or smaller deployments. Kubernetes, on the other hand, doesn't actually build the containers. Instead, it's like the conductor that takes those containers and orchestrates, scales, and automates them across a massive global cluster of multiple machines.
Just imagine your app goes viral. Kubernetes acts as this ultimate automated manager. It uses built-in service discovery and load balancing to instantly route that massive influx of traffic. As demand surges, it auto-scales to handle the load. If a container crashes under pressure, no problem. It self-heals by instantly spinning up a replacement. All of this happens while letting you perform rolling updates with zero downtime. It's an entire ecosystem built specifically for managing clusters under real-world pressure.
So what does this all mean for you? Well, it brings us to the end of our explainer and leaves us with one final critical question to consider. Is your next project ready for just Docker, or do you need the full orchestration might of Kubernetes? Understanding the foundation of Docker containers is the essential first step no matter which path you take. I really hope this breakdown helped clarify these incredible tools for you. Keep learning, keep building, and we'll catch you in the next explainer.